Hello, welcome to another module in this massive open online course. So, in this module, alright, let us start looking at a new topic, that is entropy, okay, which is one of the most fundamental aspects of information theory, which we are going to define shortly. Okay, so this is entropy. Okay, so we have seen in our discussion that ISI, the information per symbol with the corresponding to source alphabet SI is log 1 to the base log 1 over pi to the base 2 bits, correct, right? And well, pi, we have seen this is nothing but the probability of the symbol SI, and we have seen that ISI, this quantity tends to infinity as pi as a probability, as basically pi tends to 0, and ISI tends to 0, that is for certain events, that is when the event occurs with probability 1, ISI tends to 0, information tends to 0. Alright. So, frequently occurring events have less information, rare events have a higher amount of information associated with them. Okay. Now, the average information, okay, the average information of a source can now be defined as the average information of source S. Well, average information of source S is simply the expected value, this is I of S, which is the expected value of I of, well, expected value of I of S, which is basically nothing but, well, this is summation I equal to 0, summation I equal to 0 to m minus 1 log 2. So, this is pi log, or let me write it this way, this is pi times the information, that is probability of symbol I times the information associated with symbol I. So, we are computing a weighted average. So, this is equal to pi log to the base log 2 to the base 1 over pi. Okay. And this quantity, it is expected value of S, this quantity is termed as H of S. H of S equals pi log 1 over pi to the base 2. This is termed as the, it's a fundamental quantity of information theory, is termed as the entropy. This is termed as the entropy of sources. Okay, so this is termed as the entropy of source S. So, it is basically information of symbol I, this is your information of symbol I weighted by the probability pi. weighted by its probability of occurrence. So it's the expected value, it's the average information of the source, which is obtained by weighing the information of each symbol SI, that is ISI, with its probability PI, and summing over all the alphabet, summing over the entire source alphabet. Alright. So this quantity is termed as the entropy of the source, and as we have said, is a fundamental quantity in information theory. It characterizes the average information per source. The average it characterizes. So this characterizes entropy characterizes or quantifies the average information content average information of the source, average information of the source as in the information, average information per symbol. One can also think of average information per symbol emitted by the source. Emitted or generated. Emitted or generated. This can also be thought of as entropy, can also be thought of as average uncertainty. It is the average average uncertainty associated with the source. So more uncertainty also implies basically more randomness, or so more uncertainty, so more uncertainty implies more information. So it can also be thought of as the average uncertainty, right? So the symbol, what is, we are uncertain about the next symbol that is going to be generated about the source. All right, there is which means that there is greater uncertainty, which captures the fact that there is greater information in the symbols generated by the source. If there's a greater certainty, if you know for sure what the, or if you know with great certainty what the next symbol that is generated by the source is going to be, that means on an average there is less information in the symbols, or less information content in the symbols that is generated by the source. Right, we are going to see this also, of course, as we proceed through subsequent aspects or subsequent examples of entropy. Okay. Now let us start by looking at some simple properties of entropy. If you look at the definition of entropy, which is pi log 1 over pi. Now observe that, well, pi greater than or equal to 0, less than or equal to 1 over pi less than or equal to 1. This implies, well, 1 less than or equal to 1 over pi less than, so 1 over pi is always basically greater than or equal to 1, which implies log 1 over pi to the base 2 is greater than or equal to 0, since 1 over pi is greater than or equal to 1. So pi is greater than or equal to 1, log to the 2 to the base 1 over pi, log to the base 2 1 over pi is greater than or equal to 0. So pi is greater than or equal to 0, correct? Log 1 over pi to the base 2 is greater than or equal to 0, so this implies both of these are non-negative quantities. So, therefore, pi log 1 over pi to the base 2 is greater than or equal to 0 for each I. So, this is basically, this entropy is the sum of non-negative terms implies H of S is also greater than or equal to 0. So, entropy is non-negative. Correct? Entropy, it can be 0, but it cannot be negative. In fact, we will see examples where entropy is 0. So, entropy has to be greater than or equal to 0. So, this also means that the information content of a source cannot be negative. It is non-negative. It is either 0 or greater than 0. Entropy of a source, the information content of a source has to be greater than or equal to 0. Okay. So, this basically means that the information content of source is greater than or equal to 0. Further, observe that if pi equal to 1, then pi log to the base 2 1 over pi equal to 1 times log to the base 2 1 over 1, this is 0. So, this is equal to 0. So, this quantity equals 0 for pi, well, for pi equal to 1. Now, what happens if pi equal to 0? What happens to this quantity pi equals 0? If pi equals 0, let us look at this quantity pi log to the base 2 1 over pi, which is equal to, I can write it as log to the base 2 1 over log to the base 2 1 over pi divided by 1 over pi. Now, you can see here that both the numerator, that is, if you look at this quantity here, numerator and the denominator tend to infinity as pi tends to 0. As pi tends to 0, both the numerator and denominator tend to infinity. So, this is undefined. Okay. So, this expression at 0, in that sense it is undefined. So, let us look at the limit as pi tends to 0, and naturally if both the numerator and denominator tend to infinity as pi tends to 0, we can use the L'Hopital's rule, right, which is a rule in calculus to evaluate the limit. So, correct. So, now let us calculate the limit of this as pi tends to 0, that is log the base 2 1 over pi which is equal to, well, I will write the numerator as minus log to the base 2 pi 1 over pi, which is equal to, now again I can differentiate this. I can take the derivative of the numerator since it is ill defined on substitution of 0, I can take minus log 2 to the base pi. I can differentiate the numerator and denominator, differentiate the numerator and denominator with respect to pi. This is termed as the L'Hopital's rule. Which is basically from calculus to evaluate correct at the limit of precisely such quantities which are ill defined. Okay. Now, if I substitute this, that becomes limit pi tends to 0. If you look at this, that becomes, well, the numerator is, well, d by d minus log pi to the base 2. I can write this as pi to the base, that is your traditional logarithm, to the base e into log e to the base 2 divided by, well, I can differentiate with respect to pi, that gives me minus 1 over pi square, and finally differentiating the numerator, I get minus log minus derivative of log is 1 over pi minus log into log e to the base 2 into pi square. From the denominator will come to the numerator. So, this is basically limit pi tends to 0, well, pi into log 2 e to the base 2, which is equal to 0. So, basically what we have established is, if you look at this, is limit, that is, since we cannot directly substitute pi equal to 0 into pi log 1 over pi limit pi tends to 0, pi log to the base 2 1 over pi also tends to 0. So, you can say, so, and also remember, we have also seen before that pi log to the base 2 1 over pi equals also equals 0 for certain events, that is for pi equal to 1. So, we have seen that for both what we have seen is that for as pi tends to 0 or for pi equal to 1, the average information, that is pi log to the base 2 1 over pi is basically 0. That is for both events which occur with probability 1 and events which tend to occur with probabilities close to 0, or the rarest of the rare events which rarely occur, which means the probability of occurrence is close to 0 for both such events, both types of such events, the average information associated with them is 0. And this is this can be understood as follows, that of course, as we have seen, events which occur very frequently, that is with probability close to 1, naturally the information associated with them is 0. So, the average information associated with them is 0, as we have seen before. But what we have seen is that although information associated with the rare events which have probability close to 0 is very high, since they occur extremely infrequently, the average information associated with them is also 0. All right. So, pi log to the base to 1 over pi is 0 when pi equal to 1 or when pi is also close to 0. Okay. So, that is an important point. Okay. So, this basically shows that this is basically equal to, so 1 over pi log to the base 2 to the base. So, what we have seen is pi intuitively this is close to 0 for both very common and very rare, very common and very common, meaning pi approximately equal to 1, very rare meaning pi approximately equal to 0. So, that is what we have seen. Okay. So, alright. So, in this module what we have seen is basically we have defined a very important quantity which is the entropy, alright, which is basically the average information associated with each symbol of the source, which is expected value of the information per symbol, that is ISI of the source, which denotes the average information that is associated per each symbol of the source. We also said this characterizes the uncertainty associated with the source, alright, which is also basically used to characterize or quantify the information content of a particular source. Okay. And we have also seen that pi log to the base 2 1 over pi is equal to 0 when pi is 1 or pi is very close to 0. Alright. So, we will stop here and continue with other aspects in the subsequent modules. Thank you very much.